Hey everyone, welcome back to Amit Dhakad AI. Today we will continue the statistics measure of dispersion. So with the deep of focus on the most two important ones, variance and standard deviation. So first we will see what is dispersion. Okay. So dispersion, like we can calculate mean, median and mode. So all this will tell us about the center, but they don't tell us about the spreading the data, how the data is spreading. Okay. So we will take one example. So we have two students, okay? Student 1. So he have 68, 70, 71, 69 and 72. And we have student 2. He has 40, 95, 55, 90 and 70. Okay. So you can see this data, this student has almost all the data nearly 70. Okay. So the average is for this one is 70. And for this one also average is 70. But this student has like 40, 95, 55. So this is spreading in across. Okay. So this is the spreading. So this is we are looking. So this is called exact the measure of dispersion. So how the data is spreading. Okay. So before we continue the how we can use this. Okay. So first we will see the variance. Okay. So before we continue the variance, so in this video we learn about the two option only, the variance and standard deviations. Other than we have types of other measures of dispersion, like we have range. Okay. So range we calculate using the max value, max minus min. Okay. Next we have quartile deviation. Quartile deviation. We calculate this Q3 minus Q1, okay, and divided by 2. Next we have mean deviation. This we calculate using summation, okay, x minus a divided by n, okay. So a can be mean, okay, median or mode, okay. So these three are the types that you can, if you want to learn, you can learn, okay. So next we will continue with the standard variance first. Okay. So what is the variance? Okay. Variance is the average of the square deviation of each data points from the mean. Okay. Why square the deviation instead of the averaging them? So without squaring, positive and negative deviation cancel out and the average always equals to 0. Okay. So it will be like useless measure. Next we have squaring penalize larger deviation more heavily and outliers should count more than near average value. Okay. So we have population. Like population variance. We have sample variance. So what is the formula for population variance? We have sigma square, okay, summation I equals to 1, okay, to n, and we have xi minus mu square divided by n. Okay. Next we have s square. This will be summation I equals to n. Okay. So you remember this n, for population we use capital N, for sample we use the small n. Okay. And this will be xi minus x bar, the mean. Okay. And square divided by n minus 1. Okay. So these two formula we are having to calculate the population variance and sample variance. Okay. So first here why we are dividing by n. Okay. So when we calculate variance from sample, so the sample mean, this x bar, okay, sample mean x bar is calculated from the same sample. Mathematically, x bar is always the value that makes the sum of square deviation as small as possible for the specific sample. Okay. So squared deviation from x bar tends to slightly underestimate the true population spread. So dividing by n minus 1 instead of n correct this bias. Okay. So I will. So what we call this for? Basel's correction. Okay. So if I write this one, so first why we divide by n minus 1. Okay. So sample variance is divided so that sample variance becomes an unbiased estimator of the population variance. Okay. So this is called the Bayesian correction. Okay. So we saw this one and we saw the formula. So how we calculate this? Okay. So we'll see one example. So first, how we can calculate for this the variance. Okay. So first we need to calculate the first mean of the data. Okay. Mean of the data. Next we have to subtract the mean from the each value. Okay. Subtract mean from each value. Okay. Third we have square each deviation. Okay. So that value calculated, that we need to square. So deviation, and we have to deviation square. Okay. Fourth we have add up all the squared deviation. Okay. And fifth step we have divide by n. Divide by n. So it can be n minus 1 also. Okay, so this is the formula that we are using. Okay, so what was the formula? So I will write here again, summation I equals to 1 n, okay, xi and mu and square divided by, and other one is the summation I equals to 1 n, okay, xi minus x bar square divided by n minus 1. So these are the steps. Okay, so we will see the one example here. Okay, so we will take one example. Okay, so we have marks of the student out of 10. Okay, 4, 8, 6, 5, 3, 9, 7, 8, 6, 4. Okay, so first step 1, what we need to calculate? We need to calculate the mean. So I will calculate 4 plus 8 plus 6 plus 5 plus 3 plus 9 plus 7 plus 8 plus 6 plus 4. Okay, so we'll add this one. So we'll get 4, 16. We'll get 60. Okay, so now we have to divide this by n. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. Okay, so we'll get the 6. So next step, deviation squared the deviation. Okay, so this we got mean. So I will do the, so we have here n or x. Okay, here x minus mean we will have. Okay, and we here we have x minus mean square. This is the deviation. Okay, so this will be second step and this will be third step. Okay, so we have 4, 8, 6, 5, 3, 9, 7. Okay, 8, 6, 4. Okay, so x minus mean, what we have mean we have 6. Okay, we will get minus 2, 2, 0, minus 1, minus 3, 3, 1, 2, 0. Okay, minus 2. Now we will square this. 4, 4, 0, 1, 9, 9, 1, 4, 0, 4. Okay, so this value we will get. So this will be x mean and this will be x mean square. Next, what was the steps we had? We have sum of the all these values, right? Like square sum of the deviation square. Okay, we will add this one. 12, 4, 4, 9. We will get 36 here. Okay, so this is the square sum of the deviation square. Now what we have to divide? We have to divide this by the, so this is the fourth step. Okay, so now we have to divide by the n or n minus 1. So this is the fifth step. So we have 36 divided by n. This will be for sigma, right? And n what we have? N we have 10, right? So it will be 3.6. Next we have n minus 1, right? Divided by n minus 1. We have 36 divided by n minus 1. So n minus 1, what will be that? It will be 9, right? So we calculate, it will be 4, right? So this is how we can calculate the variance. Okay, so for this, if you have any doubt, you can ask in the comment section. So we completed how we can calculate the variance. Okay, so first we go through again the all the 5 steps. First we need to calculate the mean. So we calculate the mean, we have to add all the data and we have to divide by the n. Okay, so we calculated, so we get 60 plus 10, so we got our mean. Next step, we have to calculate the x minus mean. Okay, so it will be x is this element, the xi. Okay, this is the first, second, third. Okay, so this x minus mean. Okay, so after that, next step, the third step is the x minus mean square. So we already calculated the x minus mean, so we have to square this one. Okay, so we are getting this value. Fourth step, we have to sum all these squared values. Okay, the deviation. So it will be 36, and we have to divide n or n minus 1 based on the our population or sample data. Okay, next we will continue the standard deviation. Standard deviation. Okay, so standard deviation is the square root of the variance. Okay, so square root of the variance. And how we calculated the variance? Variance we calculated sigma square equals to summation I equals to n xi minus mu square divided by n, and next we have summation I equals to 1 n, okay, xi minus x bar square divided by n minus 1. So this is how we are calculating the variance. So square root of this one, so we square root this one, so what we will get? We get sigma equals to summation I, okay, my I equals to 1 to n x I minus mu square divided by n and square root of this one. So this will be the standard deviation. Okay, so it brings the measure of spread back into the same unit as the original data. Variance of marks is expected in the marks square, so which isn't intuited. Standard deviation gives the answer in the plane marks. Okay, the formula we already saw. This is the sigma under root variance. Okay, so we can say we have standard deviation equals to under root variance, right? So above we got sigma square, right? For population we got I think 36. Okay, and sample data we got I think 4, right? Okay, so how we calculate? We already calculated the variance. We have 36 and 4, and we under root this one. Okay, 36 and under root 4. So here we will get 2, right? And here we will get around 30, I think 3.6 we had, right? We divided by 10. We scroll. Yeah, 3.6, right? 36 is the square of the variance. We have 3.6, so we will get around 1.9. Okay. So this is how we can calculate the standard deviation. So we learn about how we can, what is the variance and standard deviation. Okay. So we have some properties of the standard deviation. Okay. Properties. So first, ST is always greater equals to 0. Okay, so the standard deviation will always be greater equals to the 0, and standard deviation equals to 0 only when every value in the data set is identical. Okay, so when we have standard deviation is always greater equals to 0, and 0 we have for all the values we have identical in the data set. Okay, and next we have, or if we add any constant value in the standard in the constant for every value. Okay, so adding and subtracting, adding and subtracting constant, constant from every value does not change. Okay, does not change the standard deviation. Okay, so if we add any constant value from all the data points, so the standard deviation will always be the same. Okay, and we, if we multiply with the constant k, okay, k constant, we multiply every value with the k. Okay, so the standard deviation will also be multiplied by the k, and variance will be multiplied by the k square. Okay, and standard deviation is sensitive to outliers. So what is the outliers? Outliers we saw in the last video when we are learning mean, median, and mode. So you can check out that video. Okay, so I will add the link in the description. So we have outliers here. Okay, so we have any outliers, so it will be the standard deviation is the sensitive with this one. Okay, so it will extremely inflate the value of the standard deviation. Okay, next we have a smaller standard deviation, means data is tightly clustered. Okay, and large means data is spread out. Okay, larger standard deviation means data is spread out. Okay, so this is the, we are learning measure of dispersion. So we learn about the variance and how we can calculate the variance and the standard deviation. Okay, so first you need to calculate the variance. For that we learn the 5 steps how we can calculate the variance. First we need to calculate the mean. After that we have to subtract that mean and we have to square. Okay, after that we have to add all the data, the squared value that we call deviation. Okay, and we have to divide by the n. And what is the standard deviation? Standard deviation is the square root of the variance. Okay, so this is all about the measure of dispersion. So you can ask any question you have in the comment section. So please like, subscribe, and click on bell notification icon for more updates. Okay, so in the next video we will see the how we calculate this using the numpy. Thank you.